Today we are going to discuss the function generator and arbitrary function generator. Let's see the first video.
Good afternoon everyone. My name is Vishwas and here is my friend Bharat Training. Today we are going to perform the function generator and arbitrary function generator experiment. This function generator probe is connected through TTL to the DSO. As you can see, we obtain square waveform because TTL only gives us a square waveform. After switching it to function probe, as you can see, we can obtain various functions as a triangular waveform, square waveform, sine waveform,
Also
and also
square waveform as well. So other section which help us change the frequency and amplitude of the signal. Here we can change the frequency. There are a few ranges given over here. So we can coarse select over here. Probes. One is the coarse change and one is the fine change. So we can fine adjust the frequency according to, as you can see, the frequency is changing on the DSO. There is also the ATTN function which help us to generate waveforms of very small amplitudes using the function generator.
you can obtain various waveform of value 1 milliampere,
10 millivolts,
volts.
etc.
As you see in the video, how the function generator gives us a different output and how you can obtain that view that output in DSO. Let's now see the block diagram of a function generator. Here is the block diagram of a function generator. Here the frequency control, current source and indicators are the main circuit of the function generator. This constant current source 1 and 2 are controlled by this frequency control network, and there is always constant current is provided to the integrator all the time by the current source 1 or 2 depending on the phase. Because of this, the integrator voltage level increases proportion with the time, and this output of integrator can be given as equation V out equals to integration of I dt upon minus C. Minus C is the capacitance of this integrators parallel with integrator. Any change in the current level, either increase or decrease, correspond to the change the output voltage slope and thus regulates the frequency level. Also, function generator has a comparator and multi-vibrator devices to trigger the change in the phase of the output voltage as the integrator are precisely defined peak level. As because of the change in phase, the current supply from source 1 stops and the source B starts to supply the power to the integrator. Because the source B providing power, the integrator generates the reverse current. This reverse current results in a drop of voltage in integrator's proportionality with time. Therefore, the output of a integrator is a triangular waveform where its frequency is based on the current supply of both the current sources and the comparator output is square waveform. The circuit also has a diode resistance that modifies the triangular waveform, having the minimum distortion of nearly 1% and amplifies at an output stage, a system providing the two waveforms resulting in using an oscilloscope. In arbitrary function generator, the digital data is stored in a waveform random access memory, in which the cathode ray oscilloscope is used to measure the waveform in which the data is sampled. A digital to analog converter is used to read back the memory location and feed the data points, thereby reconstructing the waveform at any time from analytic sampling theorem, which is Fs equals to 2 FM. Fs is a sampling frequency and Fm is a maximum frequency component of sampled signal. If this condition is satisfied, then we can achieve better output. Therefore, the detail of the need signal discover which requires as many points as necessary for digital data stored in RAM. Actually, the storage data points are read by arbitrary waveform generator whose limits are specified, but in instructions, usually the operating frequency or sample rate of this instrument is specified in terms of samples per second or G samples per second. Here we can also see the points which I explained just now. These are the application of function generator and arbitrary function generator. The signal testing, validation in network electronics, waveform simulation of device calibration, scientific experiments requirement, and many more. You can also download this PPT, the link given below in description. And if you have any doubt, you can ask in comment.